Operations with vectors. So this is one of those secret problems, or the ones that sneak up on you. Is because there's 1, 2, 3 things that you have to do for each of these. Ew. You said ew. Ew. Okay, so let's say you were working on a problem like number 23. Okay, number 23 has u defined as that and v defined as that. But there's also an I and a j in there. What the heck is that I and the j? I and j, those are unit vectors. Okay, so I looks like this. He is 1, 0. And then j, he looks like this. He is 0, 1. All right, so one of them, like the I represents the x and j pretty much represents the y. You guys tracking? Yeah? Okay. Now, I know I'm saying x and y, but this is horizontal movement, and this one's going to be your vertical movement. So I want to show you guys some neat things. You ready? I think these are really neat. Okay, so let's take A for example. Okay, so if I hit A, uh-oh, my Apple Pen died. Oh no! Okay, got a new one. Okay, so let's say you got, oh man, the tip is so big on this thing. A. Okay, so now I'm not using the white marker. Okay, so A says U plus V. All right, so I'm going to take U and add V to it. It's already set up for me. It's written in this form. And so I just go I plus J. That's the U. And then I'm going to go plus, and I'm going to add V. So let's add V now. V is 2I minus 3J. Now this is not like rocket science. How many I's do I have? There's 3 I's. And I have, is that a negative 2J? Yeah? Okay. So if you were to graph this vector, you would write it in component form, which would look like this. I mean, this is the long way to explain component form. You go 3 times 1, 0 minus or plus negative 2 times 0, 1. This is kind of a long drawn out process to say, 3 times this. Because 3 is a scalar, so you get 3, 0, and then the other one you get 0, negative 2, and all that work just to say this 3, negative 2. But like, did you really need to write all that just to get that? Heck no, you don't have to write all that just to get that point, because you see it right here. There's a 3 and a negative 2 right there. Okay. So it says find it, so I found it. That's my answer. And if I left it in terms of the unit vectors, that's what that would look like. Okay, so there's 2 ways to write that answer. But then it says sketch the resultant vector. Okay, what the heck does that mean? Okay, so let's say that we're just doing what it says. This says right here. This says U added to V. Now, what is U? U is U is okay. U is 1, 1. That's the vector for U, right? Right, that's what U is, 1, 1, because it's a coefficient of 1 on the I, a coefficient of 1 on the J. And then what is V? What's my V vector? 2, negative 3, right? Right. Okay, so let's say we graph these two, but we're going to add them together, okay? So this one says 1, 1, which means right 1, up 1. So I'm going to go right 1. Starting at the origin, right 1 and then up 1. And so I'm right here right now. Okay? And then this one says right 2, down 3. You guys still with me? Right 2, down 3. So I'm going to right 2, 1, 2, and then down 1, 2, 3. Okay, so that means I draw my vector like this. Okay, you guys with me? Okay, so the first vector starts at the origin. The next vector just starts at the end of the previous vector. But look at that. Look at that. Do you guys see it? So when we added them together and did all that algebra stuff, we got 3 minus 2. So that'd be right 3, down 2. If I went right 3, 1, 2, 3, and then down 2, that would put me at right here. So we end up at the same spot. So it's almost like you can say this green guy took this long route and this red guy right here took this really direct route. But they end up giving you the same vector. They give you the same location. Does that make sense to you guys? Yes, no? Yeah, no? Okay. So we would do the same thing with the B and with the C. Okay, let me try one more with you guys. Let's go ahead and do C. We'll skip over B. Because C has some other multiplying. It has some scalars in front of the vectors. So this one says 2 times U. And this one says negative 3 times V. So I'm going to have a 2I plus 2J. And then it says plus. Well, actually, it doesn't say plus, but I'm going to say that this is a negative 3. So I'm going to say plus. And then I'm going to distribute the negative 3 to the V, and my V has a 2I and a negative 3. So negative 3 times 2 would be a negative 6 I, and then a positive 9J. Okay, and then when I add those together, simplify it up, combine like terms, I get negative 4I, and then plus 2J. So we get the opposite of 4I's, and we got a positive 4 or 2 J's, and another way to write this would be negative 4 2. So this is the answer. We found that analytically. Let's also find it graphically, mostly because I think that's neat. Let's see. Let me get me some space here. Okay, first it says 2 U's. So I'm going to do this one twice, and this one, remember, is 1 1. So we're going to go up, or right one, up one, and then from there we're going to go right one, up one again. So we have 1 2 U's. Okay, so that's one. That's the first part. Okay, the next part is the opposite of 3 V's. Now this is V, and we're doing the opposite of this, and we're doing it 3 times, and so that's left 2 and then up 3. So starting right here, it's almost like we're drawing a new X and Y axis on it, but we're not. But we're starting right here. We're going to go left 2, so that's 1, 2, and then we're going to go up 3. So 1, 2, 3. So we're going to be right here. So that's left 2, up 3. Okay. And we're supposed to do that 3 times. So I do it again. I go right 2, 1, 2, then up 3, 1, 2, 3. And so that's going to put me right there. So there's another one of those vectors. And then I do it one more time, 1, 2, and then I'm running out of space, 1, 2, 3. Okay, so I'm going to put another dot right here. Because I had to scrunch my scale right here, it doesn't look that accurate. But there should be 3 equal lines right here, equal in distance. And that's very important with vectors. Vectors, remember, distance and magnitude. Magnitude are direction and magnitude. Magnitude is the distance. Oh, and I just realized, dang, I messed up right here. That's not a 2. 2 plus 9 is 11. That should be 11J, so that should be an 11 right here. So negative 4, 11, and that actually makes more sense too, because if I go left 1, 2, 3, 4, and then I go up 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, we can go from here all the way up to there to get our same spot. So when we do this, our new vector is this black one right here. And we can get there by doing these vectors in this combination, doing 2 of the U's and then the opposite of 3 of the V's. We end up getting to the same point.